Alright guys, the next thing I want to talk about is GLMs with regularization in Spark and just how you would use it. Specifically, we're going to look at Sparkly R with H2O and MILB to solve the problems. Spark R is also an option, but Sparkly R integration is sometimes cleaner, as you'll see as we go through this. We're just going to look at a couple things. So the first thing we're going to see here is I'm just using the same examples, and you'll see I'm using the same terminology that we talked about in GLMs in BUDA535. And basically what you're seeing is the only thing that changes is you have this elastic net case implemented. And you'll see when it comes back what the summary comes back with and what it looks like and how it looks. So we fit petal length as a response, petal width and sepal length as predictors. We're going to use alpha equal to 0.1, lambda equal to 0.2. So you see what starts to happen. But now look at what happens if we use lambda equal to 10. Look at the major differences you see. You see the shrinkage towards 0, right? Then what happens if we use alpha equal to 1, lambda equal to 10? We're exactly at 0. So if we keep going with this, what we can do is we can come down here and we can penalize a logistic regression as well. So just using ML logistic regression in Sparkly R allows us to make the call and make the run, right? So when you're looking at this, what we're able to do is we're able to set alpha and lambda. The thing that this doesn't have as you're looking through it, the thing that this doesn't have is it doesn't have the cross-validation functions that you're used to. It doesn't have that mentality. The other thing it doesn't have, which we understand why, is it no longer has this idea of hypothesis tests. It's hard to do. It's even harder to think about. The logistic case is extremely hard to come up with hypothesis testing. So when you're looking at this, that's something to think about. Now, this is in Spark. You also have Spark in 2.0. You have ML generalized linear regression functions that you can use. But in 1.6.2, which is our current instance on the cluster, you have this. Now, as the cluster evolves and cluster changes, we'll update this and catch up with it. That'll be one of the things that changes as we go. The other piece I want to talk to you about, and I'm just going to do it on the same video. If we go in and we look at the next page, what I want you to see is I want you to see what the Spark R example looks like and why it looks like this. Now you see I'm using the same terminology. One of the reasons I'm doing that is to give you something to compare with, okay? So we're going to initiate Spark R. We're going to initiate the Spark SQL. We're going to come in, but look at what we're going to do. We're going to fit a very specific Gaussian case, okay? And all we're doing is we're saying it's GLM. This is how we're going to fit it. But look at what appears in GLM and Spark R. You get this lambda alpha combination. So when you see that lambda alpha combination, what you're able to do is pick up and move, okay? Now, as you pick up and move and you start to deal with this data and you start to think about what this is doing, it looks very, very similar. It looks very, very similar to what you've seen all along. It looks very, very similar to see how you're looking at it. But all you're doing is this lambda alpha. Now, what you've got to be able to do is you've got to come back and be able to run this cross-validation. You've got to be able to run a cross-validation with prediction accuracy. So how are you going to do that? What I want you to do is I want you to think. You guys know how to program cross-validation. So all you've got to do is get it to the intricacies in R of, hey, how do we fit? How do we predict? Now, do we really need to do like a 10-fold cross-validation in this case? Or in a setting where Spark is required, a big data setting, is it enough just to do a test train or do a 2-fold cross-validation? I want you to think about that. These are the things that you guys need to start thinking about and need to start gaining insight on. Because if you're just using like a test train, a 75-25 split, but you've got 2 terabytes of data, that should be pretty relative. That should be a relative sample as long as you've sampled correctly, right? So as you're thinking about this and with what you're doing, keep all this stuff in mind, okay? I just want to show you the rep. These are very similar to what has been done on Sparkly R's page, but I wanted to show you it works on our cluster as well, and just some of the differences. Basically, the main difference is we initialize to a yarn client. Not all clusters are going to do that. Most Spark instances that are toy examples are going to initialize locally. We initialize to an entire cluster. That's going to be one of the main differences. So, all right, guys. As always, let me know if you need anything. Let me know if you have any questions.